All right, if you have followed this course thoroughly so far, you should have a pretty good understanding of what blockchain technology is, how it works, and what are its applications and use cases. Perhaps you are excited about the disruptive potential of this new technology with all its incredible advantages. Ready for this brave, new, decentralized blockchain world? Well, not so fast. We are not quite there yet. There are some critical issues that need to be resolved first. Decentralized systems are great in many aspects, but they are inherently disadvantaged versus centralized systems in the important aspects of scalability and governance. Running consensus among all nodes on the network just takes too much time and energy. Contrast this with a network with just one central server. Surely it will run faster. But we have already discussed the disadvantage of the central server model. It has a central point of failure. Therefore, there is a trade-off between scalability and speed on one hand and security on the other hand. Blockchains at present are notoriously slow compared to centralized payment processing networks such as Visa, MasterCard, and PayPal. Bitcoin's blockchain currently can process only up to 7 transactions per second. Ethereum's blockchain is a bit faster and currently can process up to 30 transactions per second. Compare this to Visa and MasterCard, which can handle about 50,000 transactions per second. PayPal has registered a peak throughput of 450 transactions per second. Clearly, one of the main scalability bottlenecks for both Bitcoin and Ethereum is the proof-of-work global consensus mechanism. Their current architectures would need some modifications in order to scale to mass-adopted general-purpose technologies. Of course, protocol improvement proposals are being submitted constantly by the global community of developers, and the core development teams are keeping busy working on upgrades. But the technical complexity is only one side of the issue. Another side is political, and here is where the governance issue comes into play. With such broad communities of stakeholders, it is extremely hard to reach consensus on the future development of a project. Moreover, the relationships between various participants are quite complex. Blockchain networks are not corporations where the separation of ownership, power, and control among shareholders, management, board, and other stakeholders are much clearer. At least in this early stage, the governance lines in the blockchain community are pretty blurred. The list of important stakeholders includes founding teams, foundations, or other formal governing bodies, developers, miners, and crypto asset holders. All these stakeholders jointly contribute to the value of the network. To that end, they form an ecosystem in which each stakeholder group needs the other groups, and they all benefit from their mutual involvement in the system. In economics, this is called a positive network effect. The larger the network, the more valuable it is. But the great diversity of the network poses issues when decisions need to be made and everybody needs to agree to a course of action. This has been demonstrated on many occasions. Some of the most famous ones, the split of the Ethereum network after the DAO hack between Ethereum and Ethereum Classic in 2016, something we discussed previously, and the Bitcoin scaling debate in 2017. The latter unfolded over a large part of 2017, with the hot topic being Bitcoin protocol upgrade proposals regarding increasing the block size limit and implementation of a technology called segregated witness, both for the sake of scalability improvement. During that debate, a huge divide in the Bitcoin community ensued, which couldn't be resolved and resulted in a split of the network known as a hard fork between the original Bitcoin and the new Bitcoin Cash. So that's how we have today Bitcoin and Bitcoin Cash, as well as Ethereum and Ethereum Classic. Decentralized governance is quite a complicated matter. Political systems have been trying to arrive at an optimal balance of power and representation for ages. And even after so much trial and error, this balance is tricky to maintain efficiently. Representatives are necessary to streamline decision-making, but also create a center of power and render a much more centralized system than perhaps originally envisaged. So how governance in the blockchain community can be streamlined without compromising on its foundational principle of decentralization? This is the next big question after scalability that the new generation of blockchain technology is trying to resolve. Another key issue for blockchains is interoperability. Currently, different blockchains don't talk to each other and even have serious difficulty fetching data from the internet. For that, they need special intermediaries called oracles. Oracles provide interface between smart contracts that live on the blockchain and any external data they need access to. Such data may be a critical condition for the correct execution of the smart contract. Therefore, centralized oracles, being sort of middlemen, are not an ideal solution for a technology which tries to cut out middlemen and promote decentralization around the world. The next generation blockchains definitely need to be able to interconnect with each other and with legacy IT infrastructure in order to achieve global success. Privacy on the blockchain is another critical issue that needs to be addressed. For example, the financial sector is so heavily regulated that customer privacy must be preserved at all costs, and sensitive information can only be shared with regulators on a need-to-know basis. Similarly, many corporations interested in deploying blockchain technology in their internal processes probably wouldn't like their business secrets to be recorded on a transparent and immutable public ledger. The same goes to the private financial dealings of many high-profile or high-net-worth individuals. Privacy is highly valued in the Internet age, and blockchains must be able to provide this option to users if they are to achieve mass adoption. Now that we have defined the main issues, let's look at their potential solutions. On the forefront of blockchain innovation, we have novel consensus algorithms like proof of stake and its variations, as well as other cutting-edge technologies like Lightning networks, state channels, sidechains, sharding, plasma, multi-layer protocols, atomic swaps, and decentralized exchanges, to name a few. We'll look into them in more detail in the next lessons. They are being developed both as solutions for upgrading existing blockchain protocols like Bitcoin and Ethereum, and as foundations of the architecture of new emerging blockchain protocols like Cardano, Tezos, EOS, Polkadot, Cosmos, Icon, WanChain, RChain, Aeon, Zilliqa, and many others. It's getting very, very interesting. We are going to have a sneak peek into Blockchain 3.0. Stay tuned.